Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Moving on, let's talk about network attack mitigation. Because now that we have an understanding of what some of the common attacks are, we have to discuss how to mitigate them. So one of the first things we talk about when we talk network mitigation, it's this thing called defense in depth. So to mitigate network attacks, you must first secure the devices, including all the routers, switches, servers, hosts, phones, everything that's attached to the network. Basically, the goal is to provide as much depth to the security as possible. This approach is often called the layered approach. This does require a combination of networking devices and services working together. Looking at some type of network intrusion detection and network prevention systems, looking at how all of that correlates to logs and how that correlates to a SIM and how all of the different services are communicating with one another so that the security engineer can actually quickly look at them and figure out what to do based off of certain criteria. Security devices could also include things like firewalls, email security, web security, some type of AAA server that allows for authentication, authorization, accountability. If we're dealing with outside resources, a VPN. All of those are services that are critical when we're providing different layers. Another common way to mitigate attacks are going to be backups. That means verifying that we have current backups of systems that are frequently backed up based off of need, that both the backups are secure, and that we have adequate storage to do backups. Another common and actually very often overlooked type of mitigating attacks are things like updating. Is your operating system up to date? Is your antivirus up to date? Is your anti-malware up to date? And are they running? Can we make sure they're up to date? Can we make sure that they're actually being used appropriately? So we talked about AAA a second ago. AAA, authentication, authorization, and accounting. Authentication verifies who you are. Authorization verifies that you're able to do certain tasks. Accounting basically is just a way of auditing to make sure that there's records of everything that you've done. That's called AAA. Firewalls are going to be a big one. Firewalls allow us to put in rules that allow us to dictate what type of traffic is allowed. You'll notice in this diagram we may have certain resources that need to be accessed both inside and outside. So with a firewall, we can have what's called a demilitarized zone, DMZ, that allows us to have an intermediary between the inside network and the outside network. This DMZ provides a little more protection than just allowing it on the inside part of the network and then allowing internet traffic into the network. One issue is that when we say firewall, there's many types of firewalls. We have a packet filtering firewall, an application filtering firewall, a URL filtering firewall, and a stateful packet inspection type firewall. Packet filtering basically allows us to look at packets based off of IP or frames, MAC addresses, and filter based off of that. Application allows us to be more granular on the application or on the port number. URL filtering prevents or allows access to websites based off of the URL or based off of a keyword. We also have, lastly, the stateful packet inspection, where we will inspect all incoming packets and we verify that they're legitimate responses to requests from internal hosts. Those are the 4 common types of firewalls. Not the only ones, but the most common ones. Other forms of mitigation techniques are endpoint security. We already talked about administrative policies, but maybe also making sure that we have appropriate job training, that we have job rotation, maybe also ensuring that all endpoints have security training for all the users that use those endpoints, and that the endpoints are set to update and scan regularly. All of those are critical things that often are overlooked. Moving on, we have our device security. Cisco recently acquired this auto secure setting features where we can set certain criteria, like looking to make sure default usernames and passwords, making sure that they're changed immediately, access to system resources, and making sure that those accesses are restricted. These are, again, common steps that we should be looking at with the auto secure. Making sure that all services and applications are turned on as appropriate. If they're not being turned on appropriately, turn them all off. Only have the services and applications that are needed running. Often, systems are set with all of these features turned on, and all of these features out of date. So making sure that when we have a new system, we update the system as appropriate and the applications as appropriate, and disable system services and applications as appropriate, ensuring that we have the best secured device as possible. That's known as hardening. Moving on are things like passwords. Making sure that we have passwords that meet certain standards. Things like, are they 8 characters? 10 is the preferred length or more. Making sure passwords are complex. Making sure that passwords are 3 of the 4 main characters. Uppercase, lowercase, numbers, and symbols. Making sure that passwords are complex enough. Maybe making sure that passwords don't allow for repetitiveness. Like it cannot be words in the dictionary. It cannot be similar to the same password that you used last time. Maybe looking at deliberately misspelling a word so that only you know the spelling. Often called elite speak, where you replace letters and numbers. That way, you can replace an S with a 5, and you know that the 5 is an S. But it's not always about picking the most secure password. It's also about having good habits, like making sure you don't write the password down and leave it on a sticky note underneath your monitor, your keyboard. Those are actually big things that I've seen pretty regularly. The problem with that is it's about finding a nice balance, having a secured enough password that one that you can remember without having to write it down, but is complex enough so that other people won't be able to guess. And that's one of the challenges when dealing with passwords. When we're talking password protection on devices, we can actually set security controls on our hardware, assuming we have an administrative policy that dictates how our password policy for our devices should be set up. We can set things like minimum length passwords. We could do login blocks after X amount of failed attempts within a certain time frame. We can do executive timeouts. We can ensure that only protected connections are coming in if necessary. There's lots of things that we can do to protect them as long as we actually implement them. SSH is one of the big ones because by default you can use Telnet, but Telnet allows everything via plain text. So we can enable SSH and verify that it's in use, and we can then say only use SSH. That's a really good method for protecting the networking infrastructure. That way, no weak communication protocols are in use. So how do we set up SSH? 6 general steps. Configure the host name, configure an IP domain name, generate the appropriate keys, verify a local database entry with a username, make sure to authenticate against the local database using login local, and then enable SSH on the appropriate interfaces. That will allow us to set up SSH. Another thing for protecting end devices are things like disabling unused services. If you do not need port 20 open, you're not using FTP, shut those ports down. You don't need to use them. Only open the ports that you actually use. We actually have a lab setting up SSH. We have a lab doing basic configuration and setting up SSH. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.